I recently came across a declassified report on enhanced interrogation that mentioned something so absurd it sounded like a dark joke. It described a windowless cell where a prisoner was being systematically broken down, not with physical force, but with the Barney and Friends theme song, I love you, you love me, playing on a loop for 24 hours straight at deafening volume. The report described the prisoner's reaction as a total psychological collapse. To us, it's a harmless children's jingle. To him, it was a weapon that felt like it was physically flaying his mind. What's truly unsettling isn't just the cruelty of the act, but what it reveals about the innocent art form we consume every day. We like to think of music as a backdrop to our lives, something we put on to relax or get through a workout. But when you look at the neurobiology, the reality is much more invasive. Whether it's the soaring, cathartic release of Adele's Someone Like You or the calculated crescendo of a Coldplay track, these notes aren't just floating in the air. They are actively sculpting your synapses. Researchers have found that a well-placed melody triggers the same reward circuits as cocaine, sex, or a high-calorie meal. It's a rail of happiness delivered directly to the brain via the auditory nerve. But there's a catch. Because music is a biological shortcut to our emotions, it's also the ultimate tool for manipulation. It's why supermarkets play Vivaldi to trick you into reaching for the $50 bottle of wine instead of the $10 one, why dictators throughout history have obsessed over their national anthems. They understood that while the lyrics speak to the mind, the frequency speaks to the nervous system. When we put on our headphones, we think we're in control of the playlist, but in reality, the music is listening to us, bypassing our logic to toggle our dopamine levels like a light switch. It raises a question most of us never bother to ask. Is that song you can't get out of your head a gift? Or is it a drug you didn't realize you were taking?
It's just such a visceral reaction, isn't it? Just hearing that, the combination of a purple dinosaur, something that is meant to be the absolute peak of innocence.
Right.
And using it for the complete psychological destruction of a person, it's chilling.
It really is. It sounds like something out of a dystopian movie, like A Clockwork Orange or something. But as I was digging through the sources we have for today's deep dive, the torture reports, the evolutionary psychology papers, the neuroscience, I realized this isn't fiction.
Not at all.
It's just straight up biological fact. And that's what got me. A simple, almost moronic children's song has the power to literally break a human mind. It implies that the machinery inside us that processes that music has to be ancient. It has to be unbelievably powerful and deeply wired into our most basic survival systems.
That's the pivot. That is the absolute core realization. We tend to categorize music as culture or as art. It's a luxury item, something we do in our free time.
It's software.
Exactly. We think of it as software we install on top of the brain. But when you look at the biology, all the sources point in the same direction. Music is a hardware adaptation. It's not just something we do, it's something we are. And to understand why it can be a weapon.
Or a sales tool.
Or a sales tool, yes. To understand any of that, we have to go all the way back. We have to look at why this hardware evolved in the first place.
So we're not just asking why we like a catchy chorus. We're asking, why do we even have music? What is its function from a survival perspective?
We're talking about the two fundamental drives of life, really. Surviving long enough to reproduce and bonding with a group to ensure your own safety and the safety of your offspring. It all comes back to that.
Okay, let's try to unpack this. We have a huge stack of sources today, and it seems like we can structure this deep dive around three distinct and sometimes competing evolutionary stories that came out of the reading. First, we're going to look at music as a courtship display, the whole, let's call it the sex argument. Right. Then we'll shift to music as social glue, the bonding argument.
The tribal function.
Exactly. And finally, we'll bring it to the present day and look at this modern phenomenon where we use engineered sound to hijack these ancient systems, the hacking argument.
And I think it's important for you to keep in mind that these aren't mutually exclusive. They're not like competing theories where one has to be right.
They're layers.
They are layers of our evolutionary history, and they're all active at the same time. You have the lover, the tribe member, and the modern consumer all kind of fighting for control of your auditory cortex every time you put on headphones.
So let's peel back that first layer, the lover, the courtship display. I want to take you back way, way back. Reading through the notes on our ancestral environments, you get this picture of a pre-linguistic world. Before complex sentences, before written language, maybe even before controlled fire, there was sound, there was rhythm. And in that environment, being charming wasn't just a personality trait.
No, it was a survival tool. It was a raw biological signal.
So where does this idea come from?
Well, if we look at the work of someone like Geoffrey Miller, who applies a very strict, almost brutally Darwinian lens to this, he argues we've been looking in the wrong place. We keep trying to find the survival benefit of music. Does it help you find food? Does it scare away predators?
And his answer is no.
His answer is that's the wrong question. He says we need to look where Darwin himself looked. Sexual selection.
Right. And this is a detail from the sources that just blew my mind. In Darwin's The Descent of Man, he actually wrote more about bird songs than he did about human music.
He did. It's fascinating, isn't it? In a book about the evolution of humans, he dedicates about 10 pages to birdsong and only 6 to human music. But that's because he saw them as the same fundamental process.
What is that process?
It's the pattern you see all over nature. Typically, the male of the species produces a complex, loud, energetic display, a song, a dance, a bright color to attract the female.
So that robin you hear singing outside your window at 5 in the morning, he's not just happy, it's daytime.
He is not doing it for the love of art. He's not warning his friends about a cat. He is, to put it bluntly, trying to get a date.
He's broadcasting.
He's broadcasting. And we have to look at the cost of that broadcast. This is the key to the whole biological argument. Male songbirds will sometimes sing until they literally drop dead from exhaustion.
Wow.
It burns an incredible amount of calories. And worse, it attracts predators.
Imagine you're a hawk. What are you listening for? You're listening for the loudest, most persistent singer. It's a dinner bell.
So why do it? Why take that risk?
Because it's an honest signal. It's a signal of fitness that cannot be faked. It tells the female, look at me. I have so much energy, such a strong immune system, that I can afford to waste calories and risk getting eaten just for this song.
You can't fake it. If you're sick or weak, you can't sing that loud for that long.
You cannot bluff aerobic endurance. It's impossible. So the song is proof of good genes.
And Geoffrey Miller's argument is that human music evolved in exactly the same way. That's the hypothesis. He calls it the peacock's tail theory. A peacock's tail is this massive, beautiful, but ultimately useless appendage. It's heavy, it's cumbersome, it makes it harder to fly away from a tiger. It's a handicap.
A deliberate handicap.
Yes. But if a peacock can not only survive, but thrive despite carrying around that giant tail, he must be incredibly healthy and fit. Miller says our music, our complex rhythm, our melody, our dance is the human equivalent of that tail.
How so?
Well, think about it. It takes years of practice to master an instrument. It requires immense physical energy to sing powerfully or dance all night. It doesn't directly help you hunt a mammoth or build a shelter. It's a waste of time and energy.
So if you can do it and do it well, you are broadcasting your genetic superiority. You're saying, I have energy to burn.
I have a big, healthy brain that can handle this complexity. I have strong lungs. I have time to spare. It's the ultimate fitness indicator.
Miller uses a specific modern example to illustrate this that I just loved. He calls it the Jimi Hendrix effect.
The hominid Hendrix, yes. It's a perfect modern analogy for an ancient process.
Okay, so let's break that down. Look at Jimi Hendrix. He died at 27. From a purely, staying alive as long as possible standpoint, he was a failure.
A total failure. The lifestyle, the drugs, the exhaustion, it was actively detrimental to his personal survival.
But evolution isn't just about personal longevity, is it?
No, not at all. If evolution was only about living to be 100, Hendrix would be a footnote. But evolution is about reproductive success. It's about passing on your genes. That's the only game that matters.
And in that game, Hendrix was an all-star.
He hit a grand slam. The sources talk about sexual liaisons with hundreds of groupies. He had children in multiple countries. In cold, evolutionary terms, he converted his musical ability directly into reproductive access on a massive scale.
So the theory is that back on the savannah, our ancestral hominid Hendrix, the guy who could drum the best or sing the clearest or dance the longest,
that guy wasn't just popular. He was likely doubling or tripling his gene frequency in a single generation because he was so attractive to mates. His useless skill was the most valuable thing he had.
And Miller backs this up with some pretty interesting demographic data, right? He looked at, thousands of albums?
Yes, he analyzed a huge database of jazz, rock, and classical albums to see when musicians are at their most productive. And what do you find?
A massive spike around age 30.
A massive spike. Musical output peaks right around age 30, which just so happens to be the absolute peak of mating effort in human life history.
It's the same age profile for other risky competitive behaviors.
Exactly. It maps almost perfectly onto the age profile for homicides, for entrepreneurial risk-taking, for all the things young males do to compete and show off. And historically, this creative output is overwhelmingly male.
Now, to be clear, that's a historical observation of an evolutionary signal. It's not a statement about ability.
Of course not. In the modern world, women are obviously incredible, groundbreaking musicians. We're not saying women can't make music. Miller is looking for the ghost in the machine, the deep evolutionary origin story. And in that story, he sees a costly, energetic display designed primarily by males to impress females.
It's the handicap principle again. I'm so fit, I can afford to be loud. I can afford to attract predators. I can afford to be exhausted tomorrow.
And think about the physicality of it. We're not talking about someone quietly humming a tune while they gather berries. We're talking about high energy, all-night tribal dancing, drumming for hours until your hands are raw.
It's a stress test.
It is a literal fitness test. You can't fake aerobic endurance when you're dancing for 6 hours straight around a fire. If you have a lung infection, if you're malnourished, if your joints are weak, you sit down. The music exposes the weak and showcases the strong.
So, under the sexual selection theory, that earworm you can't get out of your head has its ancient roots in a simple, brutal message. I'm healthy, mate with me. That's one powerful layer of the story. But it's not the whole story. If we only look at competition, as the soloist showing off to get the girl, we miss this other massive part of the human experience, because music isn't just about standing out.
It's about fitting in.
It's about fitting in.
And this brings us right to the second evolutionary story, the bonding argument. I want to share another account I found in the research, this one from a very different time and place. It's from a mid-20th century Soviet assembly line.
Okay.
So just picture it. A massive, gray, cavernous factory floor. It smells like machine oil and metal. You have thousands of workers, probably tired, probably disillusioned, just grinding away at these repetitive tasks. Then these overhead speakers start to blare this rhythmic, almost martial music. They called it the Red Opera.
A classic example of what they call external synchronization, forcing a rhythm on a group.
And one of the workers, a woman named Elena, she described the room completely transforming. She said, as this heavy percussive beat filled the air, you could see it happen, the workers began to move their hammers, their levers, in perfect synchronized time with the music. And she said something that really stuck with me. She said, the person at the next station, they stopped being a stranger or a rival for resources. They became part of the same body. She said they stopped being thousands of individuals and became one single massive organism.
That is such a profound shift from the Hendrix example, isn't it? Hendrix is all about standing out. Look at A.
Yeah.
The Soviet factory is about blending in. Look at US.
Exactly.
This takes us directly to the social bonding hypothesis, which is championed by researchers like Savage and Robin Dunbar and Stephen Brown.
And Dunbar has this great phrase for it. He calls it grooming at a distance.
That's the one. It's a brilliant way to think about it. First, think about our primate cousins. How do they bond? How do they build trust and form coalitions?
They groom each other. They sit and pick nits and lice out of each other's fur.
Exactly. And that physical touch, that act of service, releases endorphins. It lowers the stress hormone cortisol. It builds trust. But it's incredibly inefficient.
You can only groom one monkey at a time.
Right. It's a one-on-one interaction. As human social groups got larger and larger up to what's famously called Dunbar's number of about 150 individuals, we hit a bottleneck. You simply can't afford the time to sit around picking lice off 149 other people.
You'd starve to death before you even finish saying hello to everyone.
We would. So we needed a new bonding mechanism. We needed a way to groom the entire group at once, a broadcast signal for social cohesion.
And music is that broadcast signal.
Enter music and dance. Singing together or moving in rhythm together allows you to get that same endorphin rush, that same feeling of connection, but with 100 people simultaneously. It is an efficiency hack for social bonding.
You're basically grooming the entire tribe at the same time, but with sound waves instead of fingers.
Precisely. And we have really solid biological proof for this now. There's this incredible study on head nodding and pain thresholds.
Right. Tell me about that one.
It's so clever. They had groups of participants listen to music. One group just sat still and listened. Another group was told to tap a foot. And a third group was instructed to nod their heads in time with the beat.
So, rhythmic, synchronized movement.
Yes. And afterward, they measured everyone's pain threshold. They used, a blood pressure cuff pumped up to an uncomfortable level. Or they'd have them do a wall sit, for as long as possible, a standard pain tolerance test.
And the head nodders lasted longer.
Significantly longer.
Yeah.
The act of rhythmic synchronization with others, even just nodding your heads together, triggers a massive release of endorphins in the brain. These are the body's natural opiates. They kill pain and they create feelings of euphoria and connection.
So that's the high you feel after a really good concert or a spin class or singing in a choir.
That's the chemical basis of it. It's the endorphin rush from shared synchronized activity. It literally raises your pain tolerance and makes you feel bonded to the people who moved with you.
It's the silent disco effect. Even if you're not talking to anyone, if you're all wearing headphones and dancing to the same silent beat, you feel like a tribe. You feel safe.
And this connects beautifully to Stephen Brown's body-first model of musical evolution. We often get into this chicken or egg debate. Did we sing first or did we dance first?
What does Brown argue?
He argues we almost certainly moved first. That we stomped, clapped, and used our bodies as percussion instruments long before we developed complex melodic singing.
Why would that be?
Because our own bodies provide a natural rhythm. It's the locomotor model. The simple act of walking on 2 feet creates a tempo. A running gait creates a tempo. So the rhythm is already there, built into our biology.
And if you can get a group to sync up their steps,
you have a more effective unit. Imagine a group of early humans trying to frighten off a pack of hyenas. They all just run around randomly. It's chaos. But if they could stomp their feet together in a coordinated way.
They sound like one giant, intimidating animal instead of 12 small, scared ones.
Precisely. That mobbing behavior requires synchronization. The ability to sync your bodies to a shared pulse is a powerful tool for both defense and group cohesion. The melody probably came much, much later.
There's one more piece of biological evidence for this cooperation idea that, it's one of those things you read and you just can't unknow it. It's about the specific pitch difference between men's and women's voices.
Yes. Octave equivalence. This is a tiny detail that provides huge support for the bonding theory over the pure competition theory.
So break it down for me. Men have deeper voices than women. We all know that. Why is that significant?
Well, men are, on average, larger than women, so you'd expect their vocal cords to be larger and their voices to be deeper. That makes sense. But human male voices are much deeper than their body size would predict.
What do you mean?
If a man's vocal pitch were determined purely by his height and weight, like it is in most other primates, he'd have to be about 3 meters tall. That's 9 or 10 feet to justify having a voice that deep.
So men essentially have a built-in subwoofer that is way oversized for the chassis.
That's a great way to put it, yes. But here is the absolutely critical part. On average, the fundamental frequency difference between the adult male voice and the adult female voice is almost exactly 1 perfect octave.
And an octave, in musical terms, is the same note, just a higher or lower version. A C and the next C up on the piano. They blend perfectly.
They blend perfectly.
Yeah.
The frequency ratio is a clean 2 to 1. If men and women were just evolving to shout over each other in a competitive display, their pitches would be all over the place. There'd be no reason for them to harmonize. But because they are separated by this perfect octave, it allows for chorusing.
Singing together?
Men and women can sing the same melody together in their own range without it sounding dissonant or clashing. It implies an evolutionary design for cooperative noise-making. We are biologically built to sing in harmony, not just to shout over each other for mates.
That is just incredible. So we have the peacock showing off for a mate, and we have the tribe stomping together to bond and survive. But now we have to fast forward a few 100,000 years. We have to look at what happens when you take this ancient primal machinery and you drop it into the 21st century.
And this is where we get to the great modern mismatch. The environment has changed completely, but the brain wiring hasn't.
I want to introduce a third character for this part of our deep dive. Let's call him Kenji. Kenji is a software developer living in modern-day Tokyo. He spends, let's say, 16 to 18 hours a day inside a small cubicle staring at a screen.
A very, very different environment from the African savanna.
Completely different. And to cope with the sensory deprivation, the isolation, the crushing silence of the digital workspace, Kenji lives inside a pair of noise-canceling headphones. He has lo-fi hip-hop beats to study to, or some hyper-engineered pop music on a loop for hours and hours on end.
This is a scenario millions, maybe hundreds of millions of people are living right now. We're using sound to build a private wall, not a public bridge.
And here's the irony that I really want to get at. His brain, this ancient piece of hardware that evolved for those all-night tribal dances or those flashy courtship displays, it's now being fed a perfectly predictable algorithmic loop. The music is designed by a machine to trigger his dopamine just enough to keep him focused on the screen.
One of our sources calls it auditory cheesecake.
That's the term. It's originally from Steven Pinker, but it applies so perfectly here.
It does. Think about actual cheesecake. It has more sugar, more fat, more calories than anything you would ever find in nature. We didn't evolve to eat cheesecake. We evolved to desire ripe fruit and fatty nuts. But cheesecake hacks that ancient desire by providing a super stimulus.
A concentrated dose of what our brain craves.
Exactly. Modern engineered music is the same. It is perfectly crafted to hit our brain's reward centers, but it's divorced from its original context. It's all the caloric pleasure of social bonding with none of the nutritional value of actual human connection.
So why does Kenji's brain love it so much? Let's get into the neurobiology. What is physically happening inside his head when he hears that lo-fi beat drop?
To understand that, you have to understand the most fundamental job of the brain. The brain is, first and foremost, a prediction machine. That's its primary function. It is constantly, subconsciously trying to guess what is going to happen next.
As a survival mechanism.
Absolutely. If I can predict where the tiger is going to jump, I live. If I can't, I die. When you listen to music, your brain is doing the exact same thing. It's running thousands of predictions per second, guessing the next note, the next chord, the next beat.
So it's a constant high-speed guessing game.
It is a subconscious one. Now, here's where the reward comes in. When the brain guesses correctly, or, and this is the really important part, when the music surprises us in a pleasing way, a little structure in the brain called the nucleus accumbens releases a squirt of dopamine.
The pleasure chemical. The reward center.
That's the one. But it's not just about getting it right. If the music is too simple, too predictable, like a metronome just ticking away, it's boring. You get no dopamine. If it's too chaotic, like random noise, it's stressful. We can't predict it at all.
So there's a sweet spot in the middle.
There's an inverted U shape of pleasure.
Yeah.
We love medium complexity. We love syncopation, for example. That's when a beat falls slightly off where you expect it to, but then it resolves back to the main pulse. That moment of tension and then satisfying resolution, that triggers what neuroscientists call a positive prediction error.
Your brain says, oh, I didn't see that coming, but I like it.
And boom, you get a big hit of dopamine. That's the feeling of groove.
And is that feeling, that urge to tap your foot or nod your head, is that the brain trying to physically get in sync with the pattern to predict it better?
It goes even deeper than that. Brain imaging studies show that even if you're sitting perfectly still, like Kenji in his cubicle, when you hear a piece of music with a strong groove, your motor cortex is firing like crazy.
So even though his body is still, his brain is dancing.
His brain is running a full-body dance simulation. It's using the parts of the brain that control movement to help it model and predict the rhythm. You are mentally dancing, whether you realize it or not.
So Kenji is sitting still, but his brain is running this insane marathon of prediction and simulated dance, all fueled by these little dopamine hits from the algorithm.
Exactly. And technology is now getting scarily good at exploiting this. You brought up the neuroenergizer concept from the sources.
Right, this whole world of binaural beats and isochronic tones. The marketing promise is that you can just put on headphones, listen to a specific frequency, and basically force your brain into a state of deep focus or creativity or relaxation.
This is the ultimate hacking of the system. The biological mechanism it's exploiting is called entrainment. We know from the social bonding research that brain waves will naturally synchronize to powerful external rhythms. That's how a tribe gets in sync.
But now we're using machines to generate that rhythm.
We're using a machine to mimic the signal of the tribe.
It's entrainment without the other.
That is the critical distinction. That's the mismatch. In the ancestral environment, if your brain was entrained to a rhythm, it meant you were with your people. You were safe. You were participating in a shared ritual. You were bonding. Kenji is entrained, but he is profoundly alone.
He's syncing his brainwaves to a YouTube stream, not to a community.
It's the biological shortcut. We get the dopamine hit of prediction, we get the brainwave state of focus, but we completely miss the human connection that the entire system was originally designed to facilitate.
So let's try to pull all of this together. We've gone from the peacock on the savannah to the Soviet factory to the Tokyo cubicle. We have this clear dual nature of music.
It really is a duality, isn't it? On one hand, you have sexual selection music as a competitive display, a way to stand out, the Hendrix effect.
The soloist.
The soloist. And on the other hand, you have social bonding music as a tool for cohesion, a way to blend in, to synchronize, the red opera effect.
The choir.
The choir. And they both run on the same neurochemical engine. It's this dopamine opioid cycle.
Dopamine for the anticipation.
For the prediction game, yes. The wanting.
And opioids, the endorphins, for the consumption, for the feeling of connection and the pleasure of the shared experience.
The liking. Dopamine says, I want this pattern to continue, and the opioids say, I like being in this shared state. That cycle is the engine of music's power.
Which brings us full circle back to the dark side. Because if you understand how to build that engine, you also understand how to break it.
And this gets to the heart of why that Barney torture scenario we started with was so diabolically effective.
It wasn't just that the song is annoying on its own.
No, not at all. Think about it in terms of predictive coding. A children's song like I Love You, You Love Me is extremely simple. It's hyper-predictable.
Right.
But when you loop it for 24 hours at a deafening volume, you're violating the brain's most fundamental needs for novelty, resolution, and control. It becomes a negative prediction error loop from hell. You know exactly what's coming. You are powerless to stop it, and there is zero complexity to engage the brain's reward system. It's a relentless, inescapable assault on the prediction machinery itself.
It's the polar opposite of the groove sweet spot. It's weaponized predictability. It's auditory intrusion.
That's a perfect way to put it. And while torture is obviously an extreme and horrifying example, the underlying mechanism is the same one used on you in more subtle ways every single day.
Like in the supermarket.
Exactly. When a supermarket plays slow, elegant, classical music, Vivaldi is a common one, they are priming you. They're using the association of class and sophistication, and the slow tempo literally slows down your walking speed. You browse longer, you feel more upscale, and you are statistically more likely to buy the expensive bottle of wine.
Or, on a grander scale, when a dictator obsesses over a national anthem.
That's the social bonding hack. They're triggering that deep, ancient oxytocin and endorphin response. They're saying we are one body moving together, just like in that Soviet factory. But they're directing that powerful feeling of loyalty and belonging toward a political regime, not just a local community.
It bypasses our logic centers. You can listen to a political speech and think, I disagree with that point. You can analyze it.
You can, but you cannot argue with a frequency. You can't debate a rhythm that is physically vibrating your eardrums and triggering your brainstem. It gets into the system before your conscious, rational mind even has a chance to put up a fight.
That's a genuinely terrifying thought. But I suppose it also holds the potential for good if we use it with awareness.
It is a tool. It's like fire. It can cook your food and keep you warm, or it can burn down your house. The tool itself is neutral. Its power depends on who wields it.
We started this whole deep dive by asking if that song stuck in your head is a gift or if it's a drug. And looking at all this evidence from the peacock's tail to the torture cell to the cubicle, it seems like the answer is, well, yes, it's both.
It is a biological key, a master key that unlocks our deepest, most ancient reward and bonding systems. Whether it originally evolved to help us find a mate or to help us build a tribe, it remains the most powerful tool we have for changing our own brain chemistry without pharmaceuticals.
So the next time you put on your headphones to focus for work, or you feel that swell of pride in your chest during a national anthem, it's worth taking a second to realize what's actually happening. You aren't just listening to a melody.
Not even close. You are engaging a piece of biological machinery that is millions of years in the making. Machinery that was designed through brutal evolutionary pressure to bond you, to breed you, or to break you.
The only thing left to figure out then is who is currently holding the remote control to your nervous system.